Lesson 7A, simple rational graphs. So it is y equals 1 over x, and we're going to graph y equals 1 over x. We're going to input values for x. Okay, so input values x, input values, and output values y. So input values, we can input any of these numbers, and even negative 11, negative 1,000, negative or positive any number. Let's do negative 10. X is negative 10. So if x is negative 10, you are plugging it in for that x right there. So that would be negative 10. 1 over negative 10. 1 over negative 10 is negative 1 over 10. So how do you graph negative 1 over 10? Negative 1 over 10 is what in decimal? What is it in decimal? 1 divided by 10. It is negative what? Negative 0.1? So at negative 10 is going to be negative 0.1. It's under, right there somewhere. Very close to the line. So I could, if I wanted to, plug in negative 9, and you're going to get negative point what? Negative what? If you divide 1 over what? What's 1 over negative 9? 1 over negative 9? Well, no, you would, okay, I didn't pass out the calculators, but it will give you some other number. So let's not do that, okay? Let's do 5. That's easier. So if we do 5, x is negative 5, then we're going to get negative 1 over 5, which is going to be negative 0.2. And negative 0.2 would be a little bit more down compared to the other one, so it'll be right there. So if I do, say for example, negative 2, if x is negative 2, plug it in here for this. X is negative 2. Then you're going to get negative 1 over 2, which is negative what? In decimal. Negative 0.5? Yes? So if you're at negative 2, you're going to go to like the half point there. And if you do plug in x equals negative 1, you're going to get negative 1 over 1. Negative 1 is negative 1. So that would be here. And if you go like in between negative 1 and 0, like say negative a half. Okay, let me do that now. Negative a half. If I plug in x is negative a half. So I have 1 over x is negative a half. What's the output to this? What's the output when you do 1 divided by negative a half? Okay, what's going to happen is this. Look. 1 divided by negative a half. If you have a whole number divided by a fraction, this denominator goes to the top and multiplies times the top number. So it's going to be 2 times 1. 2 times 1 is 2. Then divided by negative 1. So it's going to be negative 2. So at negative a half, it's going to be negative 2. So if I get closer and I say something like 1/10, negative 1/10, so it would be what? 1 divided by negative 1/10. What's the answer to that? Huh? Negative 10. Negative 10. So at negative 1/10, it's going to go way down there. The closer it gets, the more down there it goes. So that's the reason why this thing goes like this. It will never cross it. It'll go down and then like a waterfall, go straight down like that. And if you do the same thing here on the right side, say I put whatever, like 1 over 1, because if I say x is 1, that'll be 1 divided by 1, it'll be 1. It'll be up here at the top. And if I plug in 1/2, if I plug in x is 2, it'll be 1/2. If I plug in 5, it'll be 1/5. And then it'll be 1/10. So it's going to go, this time it's going to go like this. And then the closer it gets here, it's going to do that thing that I was just doing right now, 1/2. So 1 divided by 1/2, it'll be what? 1 divided by 1/2 is what? 2. Yes? So it'll be at this, it'll be 2. And then the closer it gets, it'll get closer up, it'll go like that. And never cross it. That's why this goes like this, which is better explanation than what he did. I think more exact as to why it does that. He just told you it does this and it does that, and believe it. That's really what's going on. All right. So these are called asymptotes. It has a vertical asymptote. This is called a vertical asymptote because it will never cross it, and it will never cross it. It's kind of like an on-ramp. Imagine this is a highway, and this is the on-ramp. But the on-ramp will never cross, never get on the big freeway like this. And it will never get on the freeway here either. Those are, okay. So, am I going to talk about limits? Yeah, don't worry too much about this, I guess. That's more for like, if you take trig, we'll talk more about limits here. You guys already copied this down? You guys already did, no? So, like as he was saying in the video, what did he say in the video? He said that as long as you know that the parent function has those two branches, all we got to do is translate this. So is it going to move left, right, up, or down? You should know this already from doing this too much with all these other functions. It's going to be shifted what? Left. Left 2, isn't it? Yes, left 2. So what you're going to do is draw the asymptotes. The asymptote's not going to be here and not here. It's going to move left 2. It's going to go there. It's going to go there. And that's all it did. And the asymptote's still going to stay there and still going to stay there. And then the branches, just kind of draw them like this. And then draw the branch going like this. And you're done. That's it. That's all there's to this. All right, let's see. Man, I'm good. All right. So, what else? Domain. What's the domain? The domain is going to be all reals. All reals. X cannot equal to. X cannot equal to the asymptote. The asymptote is what? -2. And where are the asymptotes at? The asymptote, the vertical one, is going to be at what? X equal what? -2. That's the vertical asymptote, VA, vertical asymptote. And the horizontal asymptote is going to be where? At y equal to 0, y equal to 0. So what are the shifts? It's going to be shifted which, left or right? To the right 4 units. So it's going to go here, it's going to go up and down here. And then it's been shifted what? Up 2. So it's going to go up 2. It's going to go here. And then just draw the branches here. Draw it like that. And then draw it like this. And then draw the branch going like this and going like that. And that's going to be your graph. What is the domain? The domain is going to be what? All reals. X cannot equal to what? 4. X cannot equal to 4. The asymptote is going to be what? The vertical asymptote where? Vertical asymptote at X equal to 4. And then the horizontal asymptote where? At Y equal what? 2. For this particular one, the only weird thing here is this 5. Don't worry too much about that. It's just a vertical stretch. It really just kind of does look the same almost. It's just this. Watch. It's still going to be shifted what? To the right 4. Okay, right 4. It is still shifted up 2. It's not going to be here because it's going to be more stretched. So it's going to be somewhere more like over here somewhere. And it's not going to be here. It's more somewhere over here. It really doesn't do much other than vertical stretch. Yes? Yes? It's not right there and it's not right there. No? That's all it does. Nothing. Whatever. Okay, so in the video he talked about that what? It's still going to be a left shifted what? Left 3? Yes? And then what? Up 2? And then what does this negative do? Instead of going like this, it's going to be what? And like over here, no? Just reflected. all reals x cannot equal to -3 asymptotes. And you already wrote that down, and we've done this so much. If the graph of the equation is this, write it down, y equals that. If that is shifted 3 units to the right, 3 units to the right, what am I going to do with 3 units to the right? It's going to be dealing with this x, no? So if it's moved to the right, it's going to be what? Yeah, the answer is -7. It's -3, no? And then what? And 2 units up, that'll be what? +2? So it's going to be what? Y equals 1 over what? X -7 -3? Yeah. We're done. That's it.